In section 9, we're going to use point-slope form, and we're going to find lines that are parallel or perpendicular to other lines. Let's go to the very bottom and take some notes on this real quick. Parallel and perpendicular are two terms that you may be familiar with. Parallel, you'll notice the word parallel has two L's that will never touch each other if you were to draw those out as straight lines. And that is what parallel lines are. Parallel lines will never intersect because they have the same slope. You might want to write the words same slope. So parallel lines have the same slope. Perpendicular is a little bit different. Perpendicular lines intersect at a 90-degree angle. So intersect at 90 degrees. To find out the slope of a line that is perpendicular to another line, you actually take what's called the opposite reciprocal. I'll write out that. Opposite reciprocal. The opposite part means you flip the sign from positive to negative or from negative to positive. So you essentially throw on an extra negative sign, and if there's already one there, it would become positive. Reciprocal means you flip the fraction over of the slope. So for example, if you had something like a slope of 2/5, when you want to make a perpendicular slope, you would flip the fraction, the reciprocal part, to make 5/2, and you would make it the opposite sign. So it was positive before, it is now negative. Another example is if you had a slope of -3, which could be written as a slope of -3/1. The flip of that would be 1/3, and then the opposite part would be going from negative to positive. If you're wondering why that works, if you think about a line that is going down very steeply, like this one here, this is a downward line and is very steeply down, you would want to intersect at 90 degrees by having a very gradual line that is going up. So whenever you have a line that is going down, it will always cross at 90 degrees with a line that is going up. And if it is going down very steeply, if the fraction is a very large number divided out, then the other one's going to be very gradual. It's going to be a fraction very close to 0. And so that's kind of the way I like to think about how I keep those straight, those rules straight. But as the opposite reciprocal, the negative flip, is maybe another way, a little bit less technical way of saying that. So let's go up to our example problems and see if we can figure out what our slope is that we're dealing with. Because we're given a point, but we're not given the slope. We are told that it is parallel here. So we have a line through 1, 4. It is parallel to y equals 9x plus 4. Parallel means same slope. So all we need to do is identify the slope in this equation, which is the 9, or 9/1. And we have our slope. So let's go ahead and use that now. We have y minus our y1, which is 4, equals our slope of 9, which we got from our parallel line, times x minus our x1, which is the 1. If we want to convert this now to slope-intercept form, we're going to clean up this side by distributing our 9 to get 9 times x, and then we have 9 times -1 is -9. We'll copy that down to the next row. And our goal is to get y alone, so we are going to add a +4 to both sides to counteract the -4, leaving us with y equals 9x. These two are both constants, they are like terms, so they can reduce down to -5. -4, or -9 plus a +4 is -5. So right here, that is our line. Go to the next one here. We are again parallel to something, which means same slope, which means our slope for this line is going to be -3/5. So let's write out our y minus y1 of 2 equals our slope, -3/5, times x minus our x1, which is 5. And we need to continue working this out now. We've got it in point-slope form. We need to get it into slope-intercept form. So we'll distribute that to both. -3/5 x, and then -3/5 times -5. That's something you can either do in a calculator or do off to the side. You're going to get +15 over 5. It's going to reduce to +3. Over here we still have y minus 2. Our last step is to get y alone, so we want to add a +2 to both sides. And we have y equals -3/5 x, and these will combine 3 plus 2 to +5. So we have those right there. Our last two examples are perpendicular. This is the one we might need a little more practice with. We have a slope of 1/3, but since perpendicular says you need to take the opposite reciprocal, we need to flip that to 3/1, and since it was positive before, it is now going to be negative. So our new slope is -3/1 of our line that we're drawing. Y minus our y1, which is 2, is equal to our slope that we just found out, -3/1, times x minus our x-coordinate, -2. First thing, I've got a double negative, so I make that a positive. Since I'm going to be distributing, this fraction might be a little bit complicated, so I could leave it as it is, or I could just write it as -3. But either way, we'll distribute that to everything in the parentheses. I have -3/1x plus -3 times +2 is -6. And then I have my 1 on the bottom. I could also just write that as -6. Over on the left, I have y minus 2 yet. And I'm moving on to the final step. And I need to get my y alone. I need to add a +2 to both sides. And when I do that, I get those to reduce away, leaving me with y equals -3/1x. And these, like terms, will combine to -4. So it leaves me with that. And then a final example, again it's perpendicular, so we are going to look at the slope we were given and we are going to modify it by taking the opposite reciprocal. So the opposite of a negative is positive, the reciprocal flips it over to 7/1. So our new slope is 7/1. We have y minus our y1 of 3 equals our slope, 7/1, times x minus our x-coordinate of 1. We want to clean up the right side to get rid of the parentheses, so we distribute our 7/1 to both parts, leaves us with 7 over 1x. And then anything times 1 is just itself. Anything times negative 1 is just negative itself. So negative 7 over 1. On the other side, we have y minus 3. We know that negative 7 over 1 is just negative 7, so that might be a little easier to write it like that. We want to get y alone to finish this out, so we're going to add a positive 3 to both sides. Those reduce, leaving us with y equals 7 over 1x. These will combine like terms, so we're going to get a negative 4. Negative 7 and a positive 3, the negative dominates, so it's going to be a negative 4. You'll notice that for my constant, my y-intercept, I like to leave it as a whole number. For my fraction, my slope, I prefer to leave it the way it is so that it's easier to count out if I were going to graph that. And that is all of the examples that you have. Good luck on all of your quizzes.